Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into series and parallel combination of passive components in electronic industry. I'll be discussing on the four important topics in this video. First one is what are passive and active components. Second one is what are the series and parallel combination of these passive components. Third one is formula for calculating the resistor, capacitor and inductors when they are connected in series, parallel and other type of connections. Last but not the least, I'll be talking on what is the use of these particular combination of resistor, capacitors and inductors in series parallel connection and when to use them in electronics. So let's start. What are passive components and active components in electronic industry? First of all, passive components are those type of electronic components which does not require any external source of energy to function. For example, resistor, capacitor, inductors. Whereas the active components are those type of electronic components which requires external form of energy to start functioning. For example, LEDs, speakers or buzzers. Passive components are only capable of dissipating energy in the form of heat, whereas active components are capable of amplifying, switching, controlling and even converting the signals in electrical form. Passive components are used for controlling the flow of electrical energy in electronic circuit, whereas active components are the building blocks of any electronic circuit, because without active components it is very difficult to build any kind of applications or any simple practical advantageous application that we want. Although there are some components like diode which can be used as a passive component or active component based on the requirement and configuration of a circuit. Now let us talk about what are series and parallel connection in electronic industry. First of all, series connection in the sense connecting an electronic components in a sequential way or one after the another one. For example, connecting resistors in series, capacitors in series or inductors in series. In series connection, current flowing through each component will be same because they are connected in series, whereas voltage will be divided across the components. In case of one component damages in a series connection, the entire circuit may stop working, or maybe it will malfunction, which is not expected as per the design. The parallel connection means connecting an electronic components to the same point and making them parallel to each other. For example, connecting resistors in parallel, capacitors in parallel or inductors in parallel. Contrary to series connection, in parallel circuit, voltage applied to each and every component will be the same, but the current will be divided throughout the circuit. In parallel circuit, if any one component damages, then there is a still possibility that other components or the remaining circuit may function properly. But due to current distribution, there may be a malfunctions that can be expected due to failure of any component in the entire circuit. Now let's talk about the formula for calculating the series parallel combination of passive components like resistor, capacitor and inductor. For this, I'll be taking the help of EasyEDA software to demonstrate much better way. Let's consider the series connection of resistors, inductors and capacitors. First of all, if the resistors are connected in series, for example 3 resistors, then total resistance R equivalent or Rtotal is equal to R1 plus R2 plus R3 as demonstrated on the screen right now. And you can see that this is how the circuit diagram looks like and they are connected to the source like this way. When capacitors are connected in series, you can see that the total capacitance 1 by Ctotal is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is how the circuit looks like and that is the way how the source is connected to them. Now if I consider inductors connecting in series, this is how the circuit looks like and total inductance, which is Ltotal, is equal to L1 plus L2 plus L3. Here in series connection, we can notice that all the components are connected one after the another, which is nothing but a sequential way of connecting a circuit. That's why it is so called series connection of passive components. Now let us talk about the parallel connection of the same passive components. First of all, I'll consider a resistor. In this case, you can see that all the components are connected to the single point and current is distributed throughout the circuit. In case of a resistor, total equivalent resistance, which is 1 by R total, is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now let us consider the capacitor. In case of a capacitor, the total capacitance is equal to C1 plus C2 plus C3, whereas it will be adding the value to the capacitance. However, with respect to inductors, the total inductance is equal to 1 by L1 plus 1 by L2 plus 1 by L3, which is again equals to 1 by L total. This is how the parallel circuit for passive components are used in electronic industry. Now let's talk about the most important point, where to use and when to use the series parallel combination of passive circuit. Perhaps this is the most important point and very important topic to be discussed in this particular video, because without knowing the application of any knowledge, it is just a heap of memory. So we need to understand where to use them and how to use them. Let us consider 3 important examples to understand how to use these particular things. First one is voltage divider circuit. One of the most common and most widely used circuit in electronics design engineering is all about voltage divider circuit. Adding a 2 resistor or more than 2 resistor, we will dividing the voltage from higher level to lower level for maybe a sensing purpose or conversion purpose. In case of voltage sensors, this is how the principle is used. In that particular case, series connection of resistor is directly used, without which it is just not possible to convert higher level of voltage to the lower level for the purpose of sensing or for the purpose of conversion. That's why the voltage divider circuit is completely based on series connection of resistor. In that case, we will be using this particular passive components in a series connection. Second important application is when you are designing an electronic circuit, it is very difficult to identify the specific custom value of components. For example, if you want 52.5 kilo ohm resistor, which is very weird and not just available in market directly. On that time, what we are going to do, we will be using a series parallel combination of resistor to create an equivalent resistance that we want to achieve in the circuit. For example, 52.5 kilo ohm is the resistance that we require. Then we will be adding a 50 kilo ohm resistor and 2 kilo ohm resistor and 500 ohm resistor in series to make a 52.5 kilo ohm resistance. Not only to resistance, even with respect to inductors and capacitors, this is the case where we will be using series parallel combination of these passive components. Last but not the least, the third important point is, in case of designing a sensors and actuators which are used for industrial grade, the combination of series parallel resistor, capacitor, inductors will play a vital role. For example, if you are designing a circuit or designing a sensor for sensing a high current flowing through the entire electronic circuit, then it will be using a shunt resistor, or it is also called a sense resistor. On that time, using a series parallel combination of resistors with active components is very essential. In such applications of designing a sensors and actuators, the combination of series and parallel connection of electronic components plays a vital role. This is a surface level information which I am giving you just to make you understand what is the application of series parallel connection of electronic components. If you dive deep into electronic industry, you will find more variety of applications for this series parallel connection of electronic passive and active components. I hope you enjoyed the process of calculating and walking through the discussion about series parallel connection of active and passive components. See you again in the next video. Until then, happy learning. Namaskaram.